Welcome to the deep dive.
Great to be here.
Today, we're tackling, well, one of the most fundamental questions, really. How much of our existence, the fact that humans are even here, is just pure chance?
Yeah, it's a perspective that can really shift how you view things.
Yeah.
Are we some kind of evolutionary pinnacle or more like a lucky accident?
Exactly. And our guide for this is a fascinating article by the biologist Sean B. Carroll. It's called A Series of Fortunate Events, Chance and the Making of the Planet, Life and You.
Carroll's argument is pretty bold. He's basically saying that randomness, these highly unlikely, sometimes catastrophic events, they weren't just side notes in the story of life.
Not just bumps in the road.
No, not at all. He argues they were actually the key drivers, especially when you look at the path that led to us.
Okay, so our mission today is to unpack that idea, to look at these fortunate events and see how they stack up. You might end up seeing our origins in a completely new light.
So where do we start? Maybe with the big picture, like the cosmic scale.
Good idea. How likely is life in the universe anyway? And then, the trickier part, how likely is complex life? Stuff like us.
Right. Carroll touches on this, and it echoes what a lot of scientists think. Given the sheer number of planets out there, simple microbial life, well, it's probably pretty common. Odds are decent.
Single cells, bacteria, that kind of thing.
Exactly. But then you have the jump from that, from a single cell to something complex. Multicellular with specialized parts, brains, bones.
That seems like a much bigger leap.
A huge leap. And Earth's own history kind of backs that up, doesn't it?
You mean the timeline?
Yeah, think about it. Life's been here for, what, roughly 4 billion years?
Something like that.
And for almost all of that time, maybe 3.5, 4 billion years, it was exclusively microscopic life, just single cells dominating everything.
Wow, so complex life, animals, plants, fungi, that's all crammed into the last, 500 million years or so?
Pretty much, yeah. The Cambrian explosion and onwards. So if you were an alien biologist surveying planets, you'd probably find way more simple life than complex life.
That timescale alone is just staggering. 4 billion years of microbes before anything remotely like an animal appears.
It really cuts against that idea many of us have, evolution as this steady, purposeful climb towards humanity.
Right, like we were the inevitable goal. Carroll definitely pushes back on that.
Hard. He argues there's no predetermined path. Life's history, and especially ours, isn't a ladder. It's more like a random walk through a maze.
A maze that keeps changing shape.
Exactly, because the physical Earth itself, its geology, its climate, is constantly changing, often randomly, often catastrophically. And biology is tied to that physical history. It gets pushed in unexpected directions.
So not a purposeful journey, but a random walk, as he puts it.
And the key idea that comes out of that random walk is contingency.
Meaning things could easily have gone differently.
Precisely. Countless moments, countless events. If just a few key things had played out slightly differently, the whole trajectory could have changed. Maybe mammals never get their big break. Maybe we never happen.
And that's where this series of fortunate events comes in, these specific moments of chance.
These critical turning points where luck or randomness seems to have nudged history down the specific path that eventually led to us.
Okay, let's get into them. What's the first big one? Carroll highlights. It's probably the most famous extinction event.
Oh yeah, the asteroid impact 66 million years ago.
The dinosaur killer. Hit the Yucatan Peninsula. Big disaster. End of the dinosaurs' reign. Most people know the basics.
Right, and the consequence, wiping out the dominant dinosaurs, is absolutely vital for our story. It created this huge ecological vacuum.
Cleared the stage, basically.
Yeah, and mammals, which at the time were mostly small, shrew-like things, hiding in the undergrowth, probably nocturnal.
Living in the shadows of the giants.
Exactly. Suddenly, they had this incredible opportunity. They could diversify, move into all these empty niches. It kicked off the age of mammals.
But Carroll adds a crucial layer of chance here. It wasn't just that it hit, but where it hit.
This is where the contingency gets almost unbelievable. The specific spot in the Yucatan where that asteroid slammed down, the rocks there were unusually rich in certain compounds.
Like what?
Carbonates and, crucially,
Yeah.
sulfates. When the impact vaporized those rocks, it blasted enormous amounts of sulfur aerosols and co-uros high into the atmosphere.
So that wasn't just generic dust and debris. It was the type of rock.
Precisely. That specific chemical injection is what likely caused the prolonged impact winter, the global dimming, the drastic cooling that collapsed food chains worldwide from the plankton up.
Okay, so how rare is that kind of rock formation?
That's the kicker. Carroll cites geological estimates suggesting that only about maybe 1% to 13% of the Earth's surface has that specific composition, that high concentration of sulfates particularly.
Wait, 1 to 13%? That's tiny.
It's incredibly specific. So think about it. If that asteroid had hit just minutes earlier or later.
Earth would have rotated. It hit somewhere else.
Right. If it hits the deep ocean or a different kind of continental crust, which covers most of the planet, the environmental effects might have been bad, sure, but perhaps not globally catastrophic in the same way.
Dinosaurs might have survived, or at least not been wiped out so completely.
It's entirely possible. They might have recovered, continued their dominance, and the age of mammals might never have truly dawned. Our ancestors might have stayed small and hidden.
So our existence could literally hinge on a cosmic rock hitting a geologically unusual patch of ground the size of Mexico.
It really looks like it. A cosmic dice roll landing on a very specific, very unlucky number for the dinosaurs, but incredibly fortunate for us. The ultimate fluke, you could say.
Wow. Okay, that's a massive sudden event. What's the next fortunate event? This one plays out slower, right?
Much slower. Carroll points to a different kind of collision, a geological one, the ongoing smash-up between the Indian subcontinent and Asia.
The one that's still raising the Himalayas.
That's the one. Starting maybe 40, 50 million years ago, this immense tectonic collision began buckling the crust, pushing up the Tibetan Plateau and the Himalayas.
Okay, building mountains. How does that connect down the line to humans appearing millions of years later?
It's about chemistry and climate. This massive mountain building exposed truly vast amounts of fresh, unweathered rock to the atmosphere.
And rock interacts with the air.
It does. Specifically, silicate rocks react with carbon dioxide in the presence of rainwater. It's a process called silicate weathering. Basically, the CO2 gets pulled out of the atmosphere, chemically bound into minerals, and eventually washed into the oceans.
So the rising Himalayas acted like a giant, slow-motion carbon dioxide sponge.
Over millions and millions of years, yes. This huge increase in rock weathering gradually drew down the concentration of CO2 in the atmosphere,
leading to global cooling.
a long, slow global cooling trend. This gradual cooling eventually pushed Earth over a threshold, tipping it into a completely different climate regime around 2.5 million years ago, the Pleistocene ice ages.
A huge shift from the warmer world that existed before, when dinosaurs roamed and even the poles were forested.
A radical shift. And again, think contingency. What if the plates had moved differently? If India hit at a different angle, or more slowly, or somewhere else entirely?
Then maybe that massive weathering event doesn't happen to the same extent.
Right. Maybe the CO levels stay higher, the planet stays warmer, and we never enter those dramatic ice age cycles.
Which brings us neatly to the third piece of the puzzle, the ice ages themselves, kicking off around 2.5 million years ago.
And these weren't just one long freeze. The key thing was the cycles. Glaciers advancing, then retreating, then advancing again.
Driven by wobbles in Earth's orbit, right? Milankovitch cycles.
Exactly. And these cycles created really intense, relatively rapid environmental shifts, especially between wet and dry conditions. Back and forth, back and forth.
And critically, where were our ancestors, the early hominins, evolving during this exact period?
Right in East Africa, a region heavily impacted by these dramatic, wet-dry climate swings linked to the ice ages.
That sounds incredibly challenging. Constant environmental instability.
It absolutely puts immense pressure on species. You have to adapt or you die out. Environments changing rapidly tend to favor flexibility, intelligence, problem solving.
And it's during this period, the early to middle Pleistocene, with these chaotic climate shifts, that something amazing happens in our lineage.
Precisely. This is when we see the most dramatic expansion of the human brain. It roughly tripled in size over a couple of million years.
The triple, that's just huge.
It's an incredibly rapid evolutionary change. And Carroll stresses this wasn't just brains getting bigger in a vacuum. It coincided with major behavioral changes.
Like?
More sophisticated stone tool technologies appearing, becoming more varied, the controlled use of fire, increasing social complexity, presumably, problem-solving skills ramping up.
So the idea is that the unique environmental pressures created by those ice age cycles, which themselves were a consequence of the earlier continental collision, might have been the crucial driver for this explosion in brain size and cognitive ability.
That's the connection Carroll makes. He argues that this cognitive and cultural evolution wasn't just some internal biological program unfolding. It was deeply intertwined with, and perhaps driven by, the need to survive and adapt to these specific, highly variable, challenging climates created by Earth's contingent geological and climatic history.
So you take these three things: The asteroid hitting just the right spot to wipe out the dinosaurs and open the door for mammals.
Right.
Then this massive continental collision happening in just the right way to cool the planet over millions of years,
Right.
which then triggers the specific kind of cyclical climate chaos of the ice ages, particularly in Africa.
Exactly.
And that environment puts pressure on our ancestors, leading to bigger brains and complex behavior.
Yeah.
It's quite a chain reaction.
It is, and Carroll's point is that each link in that chain was highly contingent, highly improbable. Remove any one of them or change the circumstances slightly, and the chain breaks. The outcome S becomes far less likely, maybe even impossible.
It feels almost overwhelming, the sheer unlikelihood of it all stacking up that way.
And that's the core message, really. Randomness isn't just disruptive. It can be this powerful creative force, carving out new evolutionary pathways that nobody could have predicted. Chance as an engine of creation.
So, wrapping this up, we've journeyed from a cosmic perspective down to specific geological events and climate shifts. And the picture that emerges isn't one of inevitable progress towards humans.
Not at all. It's a story steeped in chance, a unique and improbable sequence of events. That phrase Carroll uses, a series of fortunate events, really captures it. Fortunate for us, anyway.
That asteroid hitting just so, that continental collision cooling the planet just enough, those specific climate cycles driving evolution in that particular direction, each step was contingent.
It really does foster a sense of, well, maybe humble wonder is a good way to put it. We're here not because evolution was aiming for us necessarily, but because of this extraordinary sequence of cosmic and planetary luck.
It's humbling, maybe a bit unsettling too. It suggests our existence is perhaps more fragile, more accidental than we like to think.
Which leaves us, and you listening, with the pretty profound thought to chew on. If our existence, our intelligence, our ability to even contemplate these questions is so deeply rooted in this unique cascade of chance events, what does that really imply about our significance or our uniqueness in the grand sweep of the cosmos?